Welcome to this lesson on percentages for IGCSE International Mathematics. Today, you will be able to express one quantity as a percentage of another, calculate percentage increase and decrease, and find the original amount after a percentage change. Percentages are a fundamental part of the IGCSE curriculum, appearing in everything from finance to geometry. The word percent literally means per hundred. As a mathematical symbol, this looks like this. Let's start with our first goal. Expressing one quantity as a percentage of another. To do this, we write the first quantity as a fraction of the total and then multiply by 100 to convert it into a percentage. For example, imagine a student scores 48 marks out of 60 in a test. What is their percentage score? We take the part, 48, divided by the whole, 60, and multiply by 100. 48 divided by 60 simplifies to 0.8. Multiplying by 100 gives us 80%. Always ensure both quantities are in the same units before you calculate. Now, let's move on to our second objective, calculating percentage increase and decrease. In many IGCSE problems, you'll be asked to adjust a value by a certain percentage. We can do this in 2 steps, or more efficiently, in 1 step, using a multiplier. To increase a quantity by a percentage, we add that percentage to 100%. For example, to increase a price of £80 by 15%, we calculate 115% of the original price. This means 1.15 is the multiplier. So, 80 times 1.15 equals 92. Therefore, the new price is £92. Conversely, for a percentage decrease, we subtract from 100%. Imagine a car originally worth $12,000 depreciates by 20%. 100% minus 20% is 80%. So 0.80 is the multiplier. 12,000 times 0.8 equals 9,600. The new value is $9,600. Using multipliers is much faster, especially when dealing with compound interest or successive changes, which we'll see in later topics. Sometimes, instead of finding the new amount, we need to find what the percentage change actually was. This is a very common exam question. The formula to remember is the change divided by the original amount, multiplied by 100. It is vital that you always divide by the original value, not the new one. Let's look at an example similar to a past paper question. A shop sells a coat. In a sale, the price is reduced from $120 to $96. Calculate the percentage decrease. First, find the actual change in price. The price dropped by $24. Now, apply the formula. We divide the change, 24, by the original price, 120. That gives us 0.2. Multiplying by 100 gives us 20%. The percentage decrease is 20%. Notice how we use the 120 as the denominator, because that was the starting point. If you accidentally used 96, you would get 25%, which is a common mistake to avoid. Our final objective is often considered the trickiest, reverse percentages. Our goal is to find the original amount after a percentage change. This is used when you know the final value after a change has happened, and you need to work backwards to find what the value was at the start. Consider this scenario: a laptop is sold for $540 after a 10% discount. A common mistake students make is to calculate 10% of $540 and add it back on. This is incorrect because the 10% discount was taken from the original price, not the sale price. To solve this correctly, think in terms of percentages. If the laptop was discounted by 10%, then $540 represents 90% of the original price. We want to find 100%. The easiest way is to use the multiplier method in reverse. Since original times 0.9 equals 540, we can find the original by dividing the new amount by the multiplier. 540 divided by 0.9 is 600. The original price was $600. Let's try one more involving an increase. A population of a town increased by 5% to reach 21,000. What was the population before the increase? The current population represents 105% of the original. The multiplier for a 5% increase is 1.05, so we divide our current total by that multiplier. 21,000 divided by 1.05 is 20,000. The original population was 20,000. Remember, to go forward, you multiply. To go backward to the original, you divide. Let us recap what we have covered today to ensure you are ready for your exams. First, we learned how to express one quantity as a percentage of another by using the part over whole method. Next, we used multipliers to calculate increases and decreases efficiently. Remember, a 12% increase is a multiplier of 1.12, while a 12% decrease is a multiplier of 0.88. We then looked at finding the percentage change itself. The golden rule here is to always divide the difference by the original value. Finally, we tackled reverse percentages. When you are given a value after a change, you must divide by the multiplier to work your way back to the original 100%. Let's check our progress. Expressed one quantity as a percentage? Yes. Calculated increase and decrease? Yes. Solved reverse percentage problems? Yes. You have now met all our learning objectives for this topic. Percentages are a guaranteed topic in IGCSE mathematics, so keep practicing these different styles of questions. Great work today.